Lucky made her debut in our little photos. Anyway, new set of notes, new unit. We're talking about the Earth. So we have spent quite a large chunk of time really grappling with these huge spaces and these huge masses out in the solar system, out in our galaxy, and out in the universe. The vast open space, right? Our universe is continuing to expand. Now we've kind of got to flip over and we've got to look at the thing that we are on, right? The third rock from the sun. So we've spent a lot of time looking at space and kind of measure, how do we measure in space and how do we look in space and what do we know about space? But now we've got to look kind of inside and we're kind of look in the Earth. Well, there are two laws that we've talked about that really come into play. Number one is the law of conservation of energy. Okay? And the law of conservation of energy states that, take a guess. All right, let's see what you wrote down. The law of conservation of energy states that energy can neither be created nor destroyed, only transferred from one form to another. So, for example, the light that's coming out of this light bulb, okay, that started out as electricity, electrical energy that traveled up the cord or wire into the light bulb. Once it got into the light bulb, that light bulb transferred or converted the electrical energy into light energy and some heat energy. So that's a transfer of energy, but it was not a loss or a gain of energy. We just transferred it from one kind to another. The other law that we need to keep in mind is very similar, the law of conservation of matter. And you guessed it, matter can neither be created nor destroyed, just transferred from one form to another. For example, right now we are experiencing the beautiful colors of fall, right? The leaves are changing, they're falling off of the tree. Well, in the spring, those leaves are not there anymore, okay? And so what happens is the law of conservation of matter states that those leaves just didn't poof, disappear. They broke down into their chemical components and were released back into the soil to then be taken up, right? So that matter got broken down and converted into different types of matter that then can be used for other things, okay? So the law of conservation of matter and the law of conservation of energy, the two laws that we truly have to understand in order to really understand this unit, okay? Now, we've talked about this. What's matter versus what's energy? I don't know. What's the matter with you? Just kidding. But there is a huge difference. Energy has no mass. It's not an object that I can hold. Energy is the ability to do work. Okay? That's all the definition of energy is. The ability to do work. All right? So, energy, the lightning bolt, right? A lightning bolt is just a shred of a massive amount of energy transferring from either the cloud to the ground or the ground to the cloud or from cloud to cloud. Whatever the case may be, it's just transferring energy. And that some of that energy is heat energy, some of that energy is light energy, but it is not a mass. I can't take a lightning bolt and measure the mass of it because it would have zero. Energy does not take up space, nor does it weigh or have any mass. Okay? We talked about the sun's energy, right? When a solar flare explodes, all of the matter is sucked back to the sun because of why? The gravitational attraction. Well, why is it that energy can leave the sun, but matter, right, substance cannot? Because energy has no mass, and therefore gravity has no force on the energy. So sunlight and heat energy can leave because it's just the sun's ability to do work. It is not mass. Okay? Where matter is anything that has mass and takes up space. Okay? We have not ever been in our life in a place where there is no matter. Right? Even the air that we breathe, we could weigh it. How much mass does that air have? There's oxygen, there's nitrogen in there. Each one of those little tiny atoms has a mass. Right? If we look on the periodic table. All the way to the desk that you're sitting at, the bed that you lie in, the toothbrush that you use to brush your teeth, all of those things, take up space and they have mass. So we consider them matter, okay? The other definition that we have to kind of get straight in our head is what a system is, all right? Maybe you, when we talk about body systems, you've heard of these different these different systems that all work together, right? Without one system, our other systems would not function as well. So we've got the respiratory system, the nervous system, the cardiovascular system, all of these different systems that work together. Well, we're defining a system as an organized group of related objects or components that interact to create a whole. Just like our body is a whole made up of smaller systems, Earth is a body made up of smaller systems that all interact together. We cannot have one without the other. There are actually four, well, technically five, but we're going to talk about four systems on Earth. And you've heard of them before, okay? You've heard of them before. We've got this green stuff. What is that? That's plant life. Anything living is the biosphere, okay? And then we've got water. Any sort of water is the hydrosphere. And then down below, we've got anything up in the air, right, in the space up there, the atmosphere. And then, what's that? We've got some lava. We've got any rocks. Anything to do with Earth is the geosphere. Okay, so those are the four basic systems. There's one other one that we're not going to really talk about. It's called the cryosphere, which is all of the frozen water on our planet. Okay. So if we talk about this, Earth's examples, Earth interior, which is the core, the mantle, and the crust, interact together as a system, right? Without the core, without the mantle, without the crust, none of them would function properly. So they work together as a system. All of the water on the planet interact together as a system, okay? So we've got tides that come in and tides that go out, and we have water that's evaporated and moved onto land and rain, and then that causes the rivers to flow and push water back into the ocean, and that is a cycle. So that's part of this hydrosphere system. All of the air particles in our atmosphere interact together to form global weather patterns, right? It's crazy to think of, but take a deep breath. The air that you're breathing could have been in Florida yesterday, could have been in Alaska yesterday, could have been in Europe the other day, right? All of us are connected in one big globe, one big system, okay? So those are some examples of these different systems. If we talk about the atmosphere, right? The atmosphere is a blanket of gases that surrounds the Earth. This provides the air that you breathe and protects us from the harmful UV sunlight coming from the sun, right? We've got the ozone layer, which is an upper portion of the atmosphere, and then we've got the different gases between the top of the atmosphere and the bottom, okay? So that's what the atmosphere is. We talk about the hydrosphere. All of the liquid and solid water on our Earth can be categorized under the hydrosphere, right? 71% of Earth's surface is covered with water. 97% of that is salt water. So 71% of the Earth is covered in water. Of that, 97% is salt water found in the oceans. Okay? The remaining 3%, which is fresh water, is found in frozen glaciers, polar ice caps, lakes, rivers, streams, and underground in the soil and bedrock. So a very, very, very small amount is this fresh water that we require to live. We cannot go live out in the ocean and drink that water. It will not suffice to keep us alive. Okay? So a couple different images, right? So here is that blanket of gas that protects us and allows us to breathe. That's the atmosphere. And then this really gives you kind of a depiction of what we just talked about, the breakdown in percentages in the hydrosphere, right? So if we look at this together, adds up to be 100% of the water on the planet. 97% of it is ocean. 3% is water. Now if we look, we break that is fresh water. Fresh water, be broken down, we've got 22% is found in the ground, right? 77% of this 3%, is frozen in the polar ice caps and glaciers. Okay, and then less than 1% is found in streams, rivers, lakes, all of those things. Pretty crazy. The geosphere, most of the solid parts of Earth. This includes all of the rocks and soil on Earth's surface and the ocean floor. This also includes the solid and molten interior of the Earth. So we talk about the crust, the mantle, the core. All of those things make up the geosphere. There's a cycle of flow between the molten interior and the solid pieces on the surface. Things like volcanism are one process where these interactions occur, right? So I know a couple years ago and last year, you've learned about these interactions. So that molten lava is interacting with the crust, the very thin skin of the apple, so to speak, that we all exist on, okay? And then the last one is the biosphere. The biosphere is comprised of all of the living things in the geosphere, the hydrosphere, and the atmosphere all together. This includes any organic matter that has not decomposed. All right? So, example, there's your picture of the geosphere. Right here's the crust, there's the mantle, here's the core. All of that works together in the geosphere. And then here's just an image of, right, we've got ocean or marine life, and we've got life on land. All of these things interact, okay? All of these things interact, and that's where we're going next, is the interaction between these four spheres. You cannot be in one and just talk about one without talking about the other three. Take this picture, for example, right? This picture has hydrosphere, we've got the atmosphere, we've got the geosphere where the plant life is found, and we've got the biosphere, right? All of these things interact. All of them interact, okay? You interact with these systems too, right? I take a deep breath. That's the biosphere interacting with the atmosphere. So, within all of these systems, matter and energy, going back to those two things, matter and energy, can move in and out of these systems at any given time, and therefore we call these systems open systems, because matter and energy can flow in and flow out. Okay? So, for example, if an organism dies and decays, that organism and its matter and energy, right? So if the organism dies, there's still energy in that body. So something dies, there's still matter, right? There's still mass, and there's still energy in that matter. That's left behind. So it left the biosphere and enters the geosphere. So I am a living object. I die. I am no longer part of the biosphere. Now I break down, and the nutrients, right, the energy that my body still has in it is broken down by microorganisms, bacteria, fungus, so on and so forth. And that's released into the geosphere for then new roots to take that energy up and use it, right? So it's the circle of life. Umidaba, doombidibidaba. I'm kidding. I'm not going to sing the song for you. Another example, right? A volcano explodes and puts tons and tons of gas and ash into the sky. This is an interaction between the geosphere, right? Volcanic explosion, into the atmosphere. Another example, when the wind blows across a lake, it creates waves. This is a transfer of energy from the atmosphere, wind blowing, to the hydrosphere. Okay? All of the systems that we talked about are open systems, meaning matter and energy can flow freely in and out of each of the systems. All right? So, what is a closed system? Okay? A closed system is where energy, but not matter. So only energy can flow in and flow out. Matter does not change. The amount of matter does not change. Okay? So matter does not exchange with its surroundings. It's called a closed system. An example is an aquarium that requires no external feeding. Right? You putting food in, that's external feeding. So if you have a fish tank, an aquarium that would require no external feeding, meaning there are objects that create food and it's a self-sustaining ecosystem, that would be a closed system aquarium. Okay? For example, in your book, this picture is shown. So we've got tea, sun tea being brewed, right? If I have that lid closed, the only thing that can enter is sun energy enters into that, heating the water. And then radiant energy can leave the system as well. But no exchange of matter. There's still the same amount of water and tea in that jug because the lid is closed. Matter cannot escape. Water cannot evaporate, and so on. Only thing that can enter is heat enters the jug, and some heat can leave the jug. But heat is not matter. Heat is energy. If I take that cap off, right? Now I can have solar energy leave, or solar energy enter, right? Sunlight enter, heat the water, and I can also have radiant energy leave. But also, matter can either enter or exit the system. So sunlight beaming down on water, what happens to it? It evaporates, right? So over time, I would see this water level go down, which means my matter is decreasing. This is an open system. This is a closed system. This is exactly how each one of our spheres, right, each one of our systems acts. I can have matter and energy enter in and leave because it's an open system. If I look at the Earth as an entire whole, matter is really not changed. The amount of matter that was on Earth when Earth was formed 4.6 billion years ago is really the same amount of matter, roughly, than we have today. Okay? So, we just talked about this, right? The system as a whole, Earth as an entire whole, is a closed system. Because matter exchange is very limited, very little dust and rock enter the system, right? So meteor showers and things like that. That's very little matter enters the system, and a very small fraction of our atmosphere escapes. Mostly hydrogen atoms escape our atmosphere. Everything else is too heavy. Earth's gravity keeps it down. So we don't have too much entering or exiting as far as matter. So we call it a closed system. Energy enters the system through sunlight, leaves as heat. So enters sunlight, leaves as heat. So heat is energy that's leaving our system. But very little matter enters or leaves the system. Okay, so that's why we're considered a closed system. All right. Since matter is not exchanged between space and Earth, the matter on Earth has to be used to make new material. Then recycled. The circle of life has to be recycled to make new material over and over and over. So, to think of maybe once I was part of an eagle, maybe once I was part of a tree, maybe once I was part of a clump of bacteria, right? The cells in my body, the energy, the components that make up my body were not always in me, right? It's over and over and over and over and over. We all interact, and the matter that's on our planet, right? The water that you drank this morning could have been in Asia, years ago. Could have been in a dinosaur's stomach when dinosaurs roamed the earth. Who knows? Pretty crazy. In class, we'll watch the ASAP video. Thanks for watching.